So we're going to represent valence electrons using dots. The valence electrons are the important ones because those are the ones in the highest principal energy level. Those are the ones on the outside. Those are the ones that get lost. Or if we're gaining electrons, those electrons go into the valence electron shell. So in the Lewis symbol, valence electrons are shown as dots around the element symbol. So we can write a Lewis symbol for oxygen. So we start with the element symbol O, and then we ask ourselves, how many valence electrons does oxygen have? 6. We know that because it's in group 6, right? So that's easy. So I'm going to put 6 dots. I could do this, but it's a little hard to see exactly how many dots are there. So instead of doing that, what we do is we confine the dots to above and below, to the right and to the left, sort of like north, south, east, and west. So I could put 1 over there and 1 over there, and I could put 2 at the top and 2 at the bottom. It's a little bit like dice, where we recognize the patterns, and so we don't actually have to count them. So that's not how we do it. So that would be a Lewis symbol for oxygen. Now, exactly where you put those electrons doesn't matter. I could arrange them like that. It doesn't matter at all. But we want to keep them top and bottom, right and left, and they can be single or in pairs, but we're not going to put 3 together. So dots are placed the maximum of 2 on a side. There's 4 sides, and this makes it easier to visualize the number. So if an atom has 8 valence electrons, we say that it has an octet. It's like if 8 people are singing together, that's an octet, right? If 2 people are singing together, it's a duet, right? Well, those smaller elements like helium and hydrogen are just aiming for a duet of electrons. But the larger ones are all going to try to get an octet. So we have what we call the octet rule, and this is an important concept in chemistry. Atoms transfer or share electrons to achieve an octet of valence electrons. So we talked about how the noble gases have 8 valence electrons, and that's a particularly stable situation. The other atoms, the other elements, are going to try to get that 8 valence electron configuration by either sharing electrons with somebody or losing or gaining electrons. And so in the Lewis model, that's driving the formation of bonds.